Everyone to my software design mini project presentation. My name is Sulakit Parinwat, and today I'm going to present a GPS Sensor Analytic program. Let's get started. The GPS Analytic basically is gathering the data, the sensor data from our mobile device using the mobile Matlab application and try to port any sensor data to the Matlab application. Our reference work are using the documentation from the Matlab public officially for the topic acquire GPS data from your mobile device and plot your location and speed on the map. This work tries to gathering out your location and speed with a timestamp from your mobile device using the Matlab application, both in iOS and Android mobile. And using the mapping toolbox, which is the add-on application on your Matlab to plot the data in the map. So our presentation view starting with the live script and then go to the app design. So we're gonna move to the live script first. As you can see, the first thing to do is gonna clear all variable, including mobile dev, and clear the M, which is the mobile device variable. And then we try to prepare our sensor enable. So in this case, we use the position sensor and the acceleration sensor. In this example, we use the iPhone for the data collection. And then we start the acquiring the data using the m.logging equal to 1, or we can call it enable the logging data. And after a few minutes, after we gathering the data enough, so we turn off the logging data. And we retrieve all the logged position data with the function post-log_m. So we will get the latitude, longitude, time, and the speed from the location sensor data. But in this example, we're gonna use our pre-trained data that called sensor log, the walk and car data. So after we have all the data that we want, we're gonna bin the speed into color value. The speed value are bin in order to use a discrete number of colors to represent that observed speed. In this case, we use the bin number equal to 10. So basically, it's gonna divide the speed into 10 portions equally. So we display the max speed and the min speed. In this case, we have 13 meters per second and 0 meters per second. And we display the bin length, which is allowed 1.3875 meters per second. And we add the infinite value to the last bin. Then we try to determine which bin is speed value it falls into. So we will have the speed compared to the bin length as this plot. As you can see, a small changing from the speed from the continuous speed to our discrete number. This process gonna make the program more faster than the continuous value. And after we have all the processed signal, we just split the latitude and longitude data into the speed. In this function, we use the GeoShape function and use the for loop. The for loop is keep only the latitude longitude value which match the current bin and leave the rest at NaN, which I interpret as the break in the line segment. To make the path continuous this by being segmented into different colors, the lat and long value that occur after the transition from the current speed into rotor speed will need to be kept. Also, the pre-allocate space for insert the extra lat and long value. And lastly, add the latitude and longitude segment to the geographic shape vector. In this case, we use the variable k. And after we already have the segment for geo shape function, we're gonna call the mapping toolbox, which is using web map, and open the state map. In this example, we use the icon map work from the toolbox to mark the icon in the map. We calculate the mean of block segment and the longitude segment with omit the NaN value, and make the color be the autumn color with the n bin number. In this case, we prepare the portion number into equal to 10, so we have 10 color in the map. So for the example, we're gonna have this figure in the screen, and after that, the additional function that we add that we add additional for the website, we computed this 10 by computed my and multiply it by the 5280, which is the distance along the sphere shape of the mapping. And then we compute the processing loop by the for loop again, starting from 1 to the length of latitude, looping through every sample data, and use the distance function to gathering the cumulative function of the distance and plotting in the app design. So we go to the app design. So basically, from the app design application, we're starting with push the start button. And after the application start, this application gonna connecting to our device automatically. As it said, connecting to the device. And after the mobile device define our Matlab mobile, it's gonna say the device ready. So for now, we can click the start button, and then I'm gonna flip my phone just a bit turn. So we're gonna rotate down, up, down and up, down and up again. Just a few rounds. And after that, I'm gonna click the stop button. The application gonna plot our according sensor data, including the speed, distance, accelerometer, and Angular. And let's see it show the map. It will take a few time to compute the mapping tool. So in this case, I don't go anywhere, I just turn up and down my mobile phone. And as the fact that my mobile phone is in the building, inside the building, so the GPS gonna quite confused about the signal. But if you go back to the live skip and use the preload data here, in this case we have walk and car data. So you're gonna click the run to the end function. It'll take a few seconds to compute the signal and mapping tool. From here, I driving car around the Chiang Rak Road, and as you can see, the difference of color represent the difference of speed along the Chiang Rak Road here. And it is the market icon, the Matlab icon. And that is for our project. So go back to our advantages and disadvantages. Let's talk about the disadvantages first. As you can see, there is many wrong signal inside the building, as no GPS signal inside the building. And the program is still too slow process, but it can be reduced by compute more technique on the Matlab coding. And it cannot run without a Mac OS or Windows device. It also cannot plot the real-time signal. But using MQTT technique, it might can plot the real-time signal, but the signal will still be a lot of delay, something like the 15 minutes for sending the signal. So it can be improved later. But our advantage for the project is it is easy to sensor analyze than scratch coding. And it automatically connects to a mobile device without any coding. And we can know the total distance from tower location data. And the fact that our position data cannot tell the distance directly. And lastly, we can get the speed along the market map. Let's say we cloning the Nike Land application, something like that. And for the future improvement, we try to improve the speed of the program by use the technique coding in the Matlab application. Maybe use the something like a NumPy in the Python, but it should be in the Matlab coding that more that is faster than using only the while or the for loop. And we try to make it real-time plotting UI, the real-time plotting GUI. And we try to make it more friendly application, including the voice, beep, tempo, and notification. For example, the notification that it might be that the offset of the maximum speed that we can drive or the minimum speed that we should run, for example. So it's gonna be like notification from text to voice speech. For example, you are too fast, please slow down, something like that. And then we analyze the running pattern from the accelerometer. So as our in-class project, we analyze many walking sensor data So this project can be improved for the future to analyze the landing pattern by gathering the data from the accelerometer later. And we try to summarize the landing speed per kilometer. So in the Nike Land application, we call it the split speed, right? So we summarize the speed per kilometer. And lastly, we try to make it available to export the log file to Matlab or local storage automatically to make the project be more friendly for another researcher to get the log file, whatever in Matlab, Google Drive, or any local storages. And that is for our project. Thank you.